Hello sir, Ronak Pashunath, and today I'll be presenting on the topic carbon credit trading and blockchain technology, where sustainability meets innovation. This presentation will cover the principles of carbon credits, how trading works, the challenges in traditional systems, and how blockchain can help overcome them. We'll also look at some of the recent advances up to 2025 and some real world applications as well. So to start with, I'll make you understand what are carbon credits. A carbon credit represents 1 metric ton of carbon dioxide avoided or removed from the atmosphere. They act as a tradable permit that can be bought or sold. These permits create economic incentives for emission reduction projects while allowing organizations to offset their unavoidable emissions. The goal is to incentivize businesses to invest in emission reduction projects such as renewable energy, reforestation, or carbon capture. With growing global focus on climate action, transparent and efficient carbon markets have become essential infrastructure for achieving net zero targets. So, if a company emits more than allowed, it buys credits. If it emits less, it can sell credits. This creates a financial incentive to reduce emissions, and once credit is retired, it cannot be reused. So as you can see, the diagram on the right represents what the carbon cycle is. It has the industrial carbon offsets, renewable captures, carbon and industrial off emissions. Next, I'll be talking about how carbon credit trading works. In the first step, credits originate from reduction projects, for example, in renewable energy, forestry, or direct carbon removal. This process is known as issuance. Next, these credits are then bought and sold via exchanges, brokers, or direct deals between the parties. This process is the trading process. Next, when credits are used for offsetting emissions, they are permanently retired from the market, ensuring that the claimed reduction is real and not double counted. This process is the last process known as retirement. As you can see the diagram on the left, it is a flow diagram which explains the carbon credit trading, wherein it consists of the emitters, project developers, retirement, buyers, and registers all getting together to do it. Next, I'll be talking about the types of carbon markets. Basically, there are two types of carbon markets. They are compliance markets and voluntary markets. Compliance markets are the mandatory government regulated systems like the EU emissions trading system. Companies must purchase allowances to cover their emissions. Some of the characteristics are legally binding caps, high volumes, and they contain standardized products as well. Next, coming to the voluntary markets. Optional purchases by businesses and individuals seeking to offset emissions beyond regulatory requirements are the voluntary markets. Some of their characteristics are they are diverse project types, they have contain growing demand, and they have a premium pricing as well. Next, I'll talk about some of the challenges of carbon trading. Despite being useful, traditional systems face big problems. Some of them are firstly double counting, where the same credit are sold multiple times due to inadequate tracking systems. Next is the fraud and opacity, where the limited transparency enables questionable projects and inflated claims. Complex verification, where the manual processes create delays and increase costs for market participants. Lastly, it contains limited liquidity, where the fragmented markets with high transaction costs reduce trading efficiency. These are the challenges which needs to be overcome. So this is where blockchain really kicks in. So I'll be talking about blockchain technologies. So some of the key characteristics of blockchain technology are blockchain is a decentralized digital ledger. That is, there is no single point of control, so there is no single point of failure as well. It records transactions securely and transparently. Each block links to the previous one, making tampering nearly impossible. It consists of immutable records, where tamper-proof transaction history. It also consists of smart contracts, which is the automated execution of agreements. Lastly, it consists of tokenization, which represents a digital representation of real world assets. That is, which allows physical or digital assets like the carbon credits to be represented as digital tokens. This is the properties of blockchain technology. Next, I'll be talking about how carbon trading and blockchain are interrelated. This diagram shows the carbon credit life cycle on blockchain. First, a carbon credit is issued by a registry. Then, it is tokenized, converted into a digital token. Next, it is traded on blockchain platforms that is peer to peer. Finally, when it is used, it is retired permanently, ensuring no double counting. This makes the system more transparent, efficient, and globally accessible. As you can see the flowchart, the carbon trading via blockchain, first the project is added to the blockchain and as the project goes, finally the carbon credits are resold and retired. You can also see the comparison between the current centralized systems, that is the old traditional systems and the new blockchain enabled systems. With blockchain, every trade or retirement of credits is recorded permanently, ensuring a complete audit trail and stopping double counting. This proves the immutable ledger. Next, automated processes covered by smart contracts reduce costs and eliminate intermediaries. This proves the smart contracts. Lastly, integration with IoT sensors and satellites supports ongoing real-time monitoring and verification of reduction projects. This is a property of real-time MRV. As you already know about the credit tokenization, carbon credits converted to digital tokens enabling fractional trading and instant settlement. Next, I'll be talking about some of the market evolutions from 2020 to 2025. Starting with 2020 to 2021, early blockchain pilots. Since 2020, some major innovations have happened. In 2021, tokenization projects like Token Protocol and Klima DAO linked voluntary credits to blockchain. In 2022 to 23, major registries like Vera introduced stricter rules for tokenized credits. In 2024, Microsoft announced large-scale carbon removal purchases. And finally, by 2025, traditional bank pilots are piloting blockchain-based custody solutions for carbon credits. This shows the growing institutional adoption and the advantages of blockchain technology in carbon trading. I'll be talking about some of the lead market applications. So firstly, Token Protocol, who are the pioneer in tokenizing the carbon credits, creating on-chain liquidity pools with Klima DAO partnership. Another one is Flow Carbon, where the marketplace platform enabling institutional access to tokenized environmental assets. The third major applicant is the JP Morgan pilots, where testing blockchain-based carbon credit custody and settlement for institutional clients are their major area. Lastly, the Microsoft procurement, where leveraging blockchain for transparent large-scale carbon removal purchasing is a lot. So some of the benefits and risks involved are benefits, transparency and accessibility, efficiency and programmability, and stronger MRB integration where enhanced measurement, reporting, and verification systems are involved. Some of the risks involved are double counting and fraud. If poorly governed, potential for double counting, greenwashing, and speculative market volatility. And lastly, some of the regulatory uncertainties are also present. Next, I'll be talking about some of the future of carbon markets. The future will likely see integration of blockchain with AI and IoT. For example, IoT sensors could automatically record emissions and upload data to blockchain in real time. So some of the examples are registry. Blockchain bridges will become standardized, registries will remain central, but interoperable blockchain tooling will improve. Next, durable removals demand. Corporate buyers will increasingly prefer verified long-term removals. For example, geological storage, engineered CDR. Next is the MRV automation. AI plus satellite or IoT plus oracles will increase timelessness and lower verification costs. Next benefit is the institutionalization. Banks, custodians, and exchanges will offer regulated on-chain products driving scale but also requiring stricter compliance. The last enhancement is a policy alignment, where the legal frameworks will emerge for tokenized environmental assets. So the transformative benefits include the enhanced transparency and trust, global accessibility and liquidity, programmable offset mechanisms, and real-time verification takeaways. So the next steps involved or the future work involved are the standardized registry, blockchain bridges, and institutional adoption will drive the next phase of the market evolution. So if scaled well, blockchain can become the backbone of transparent carbon markets. So I would like to finally conclude by telling that the carbon credit trading is crucial for emissions compensation and meeting net zero goals. Next, the blockchain technology improves transparency, efficiency, and trust in carbon markets. The period from 2020 to 2025 shows significant rapid progress in momentum but highlight governance needs. The future outlook involves the ultimate vision, that is the credible, scalable, and a tech-enabled global carbon market to be included. So thank you, sir. Thank you for giving me this opportunity.